Okay, now we are still talking about battery supply, alright, but we're going to talk about the last part of the battery supply, which is about how can we get away with a single cell. What does this mean is something that is more in depth, so therefore it's also with regards to this page. Alright, for what voltage should I design a circuit? Alright, and you may want to read all this, but to a certain extent the meaning might not be quite clear, I think. So therefore I would want to use a certain example to actually exhibit this meaning out. So the keyword is for what voltage should I design a circuit? Alright, so should I design a circuit? Okay, so for example, if I design a circuit that is about 2.1 volt, okay, then I will need to think about how many batteries should I put in. Alright, if I were to put in 3 batteries, for example, I can still supply a power of 2.1 volt, because if happen that each of the battery is 1.5 volt, 3 of it is 4.5 volt. Alright, so I can still supply batteries to my system quite well. Alright, but the problem is that I actually have a space limitation. I may want to only design within these particular dimensions. Alright, I don't want one more battery. Alright, what can I do about this? Okay, therefore this comes to a point where you need to know what type of battery should you choose, what type of design or what type of dimensions, things like that. Alright, so therefore I'll just illustrate to you this meaning now. So this particular paragraph tells you that the alkaline cells is over 1.5 volt. Alright, it's about over here, the red color line. Alright, it's approximately at first it's about 1.6 volt. Alright, and over here the last power before it fails, because 100% discharge already ma, so the last voltage it can produce is approximately 0.9 volt. Okay, so therefore if I were to put in my alkaline battery in red color, okay, my alkaline battery, okay, so each of it has 1.5 volt times 2 is equals to 3 volt. I can supply 3 volt to my 2.1 volt system, it can work. But up to a point when it reach about approximately how can I say, approximately 75%, for example 75%, its voltage supplied is about 1.1 volt, for example. Okay, so the last bit before it fails, before my product actually turn off, or the last amount of supply it turned off, is 1.1 volt times 2 is about 2.1 volt. 2.2 volt, sorry. I should say that maybe 1.05 volt lah. Okay, times 2 is about 2.1. Okay, so at this particular 75% is approximately 1.05 volt. Correct? As the graph has show you. Alright, so at 75%, alright, then after finish using your battery for 75%, you have left 25% more, correct? And your product actually stopped because it requires 2.1 volt. Alright, so you're constantly, so the last amount of power you can give is when you are 75%, alright, which is about 1.05 volt for each battery. Right, after which, alright, after the 75%, the rest of the 25% cannot power up your system because it requires 2.1 volt. Then what about this 25%? You're gonna waste your power, you're gonna waste your voltage, right? Because it's totally not good, right? Because you're designing something, yeah, you're starting to design something that is not very environmental friendly, or is causing a wastage of 25%, correct? So therefore what can we do about this? Alright, therefore what can we do about this is that this is why people say that the nickel metal hydride is better. Alright, nickel metal hydride, you see, which is this one. It's a rechargeable battery, but it's still a battery. It's the form of battery that we often see over here. But this form of battery doesn't mean it's always AA. It can be a nickel metal hydride, which is the blue color one, as you can see, for example, this one. At first, its starting voltage is about 1.4 volt, alright, and over here, eventually, its average voltage is about 1.2 volt. Alright, it's nominal. People call this the nominal, or sometimes the average. It's the same thing. The average, or the most of the voltage coming out is about 1.2 volt, which is which is this particular sentence tells you, like this particular paragraph tells you, for nickel one, it provides about 1.2 volt. Alright, so 2 batteries about 2.4 volt. You see? So therefore, if you were to use, instead of the alkaline manganese, I want to use something else. I use my nickel, my nickel what? My nickel metal hydride. Alright, the blue color one. So therefore, I choose the blue color one. I draw the blue color one. So now I'm using this type of battery. Okay, so now I'm using this type of battery. So each battery can supply approximately what? Can supply 1.2 volt lah. Okay, let's start off from here lah, because at first is the highest. Alright, up to here it can supply, from here to here, for example, it can supply approximately 1.2 volt. Alright, so most of the time the percentage is about 1.2 volt. Okay, so about 1.2 volt times 2 is about 2.4 volt. Alright, so you can still power up your machine or power up your system quite well using a 2.4 volt 2 battery nickel metal hydride system. Okay, as you can see, about at this particular point, alright, at about maybe 97%, okay, and 95%, sorry, and 97% is about approximately 1.05 volt. Alright, 1.05 volt times 2 is equals to 2.1 volt. So at 97%, after you finish 97%, alright, your battery life actually reach 2.1 volt, correct? So it can still power up, and this is the last power it can supply before it goes lower than 2.1 volt. So at maybe 98%, for example, let me see, use a different color. So at 98%, for example, over here, this is 98%, alright, this power is about 0.9 volt already. So the 0.9 times 2 is about 1.8 volt. So it cannot power up this thing anymore, because your nickel metal hydride is not able to provide the amount of power, because your system requires 2.1 volt. So the last amount of voltage you can give is 2.1 volt when it is 97%. If it's 98%, your machine or your system will off, right? Because no power anymore. It's supplying about 1.8 volt already, or maybe 1.9 volt. You cannot give power already. You have no voltage to give. Alright. So I just want to convey is that by using the nickel metal hydride, you can actually have less wastage over here, 3%, compared to just now. If you use the alkaline manganese, you have 25% wastage. You see such a big difference. Alright, so therefore in a certain sense, the nickel metal hydride is much more environmental friendly than your alkaline manganese. Okay, and moreover, your nickel metal hydride is able to be recharged. Right, it's a rechargeable battery. So this is why it's always the best choice in this present time. Why people often use the nickel metal hydride already. Alright, this is one way to design in designing your system. So what voltage should I design a circuit? So this is exactly what they're trying to say over at this page. Some products now come with instruction forbidding the use of alkaline cells or alkaline batteries. Alright, perhaps so that they can design for 2.4 volt rather than 1.8 volt. Alright, so that they can design something that is for 2.4 volt. For example, if you have a machine that is 2.4 volt, alright, if you use 2.4 volt, this example will be more clearer. For example, for 2.4 volt, for example, if you use the alkaline manganese, alright, if you use the alkaline manganese 2.4, so 1.2 volt each battery, so times 2 is about 2.4 volt, correct? So about 1.2 volt. When is 1.2 volt for alkaline battery? Alright, alkaline battery 1.2 volt is approximately here, 60%. You see, it's about 60%. Then you can the last amount of voltage you can give is 60%. After which when you reach about maybe 70%, for example, you are 1.05 volt, or you are about approximately 1.1 volt lah. Okay, so 1.1 times 2 is equals to 2.2 volt. You're unable to supply into this new system over here, which requires 2.4 volt. Alright, so you're gonna cause more wastage again. You see, you're gonna about 40% more. Alright, so normally you can put in the alkaline battery, but you are actually wasting your money and wasting your power resources and everything, because you have 40% more to use. So the choice of battery is very important, right? So the nickel, if you were to use the nickel metal hydride, alright, 2.4 volt, you see, approximately about 90%, alright, then you have about 10% wastage. Alright, so you somewhat is a little bit less efficient now, but at least compared to alkaline 60%, you see, so you have about 40% wastage. Over here for the nickel metal hydride is about 10% wastage. So but it can serve the purpose of the 2.4 volt, because the average voltage that the nickel metal hydride can supply is 1.2 times 2, which is 2.4 volt. Alright, so therefore the choice of battery is very important when you choose your design method, alright, in terms of space, in terms of a lot of stuff. And therefore the next page, since we already finished this page, alright, we'll talk about it already. So the next page is talking about capacities of different types of cells. Alright, so we talk about the capacity of a 1000 milliampere hours. I will assume you already know how to calculate this. Okay, if happen that you forgot, 1000 milliampere hour can be, if you use 1 milliampere current across 1000 hours, you can use 1000 milliampere hours. Okay, so if you have a battery that is 1000 milliampere hours, you can use 1 milliampere for 1000 hours. Nonetheless, you can also use 1000 hours to nonetheless you can also use 1000 milliampere for 1 hour to also finish this cell. Alright, so nonetheless you can also have use 500 milliampere times 2 hours. So we can use 5 milliamperes for 2 hours using this particular 1 milliampere battery. Okay, things like that. Alright, so it's just milliampere times hour, that's all. Okay, so this is just the simple calculation for this system. Alright, so the type of your system, like zinc, alkaline, or whatever, nickel metal hydride, is all here. Alright, size AA. Alright, so AA isn't straight away alkaline, but however, talk about different materials. So AA can be alkaline, can be zinc, can be nickel metal hydride, depends on it. And then for the capacity, zinc is this and this. I think you can read yourself. The cost is approximately 40 pennies, so you change to SGD is about 90 cents or maybe $1, I don't know. At least you get a rough idea of how these things actually work out, right? In this page, how can different voltages be generated? Alright, I think it's similar to the page that I've told you just now over at this side, when you design how to design your product. Alright, how to design how many batteries you need and things like that. I think it's the same thing. Alright, so for example, how can 5 volt be provided to be part of a system if the rest uses 3 volt? Alright, so nonetheless, this question may be required that you may actually have a certain small regulator to actually step down the 5 volt to a 3 volt, so that your 3 volt system can use. So for example, if I have a 2.4 volt system, although I supply 3 volt for example, alright, I will require a certain regulator inside to regulate the 3 volt into 2.4 volts, so the 2.4 volt can use also. Alright, I didn't go through this, but at least you get the meaning of that now. Alright, and I may be wrong, so yeah, just keep an open mind that I may be wrong. Then how can I run a 3 volt system using a single AA battery? How can I do this? Because sometimes your 3 volt system may not be requiring 3 volt. You may require less than 3 volt. Because because they take in account that your battery will actually follow this curve. Alright, they take in account that your battery will actually follow this discharge curve. So they will predict that in the end your battery may actually drain out significantly, like this one over here, it may actually drain out. So therefore, your MP3 itself, for example, MP3 player may not be necessarily requiring 3 volt. It may actually requires only 1.2 volt. Alright, so if you use a single battery, alright, you can also power up your Walkman, your MP3 player already. Alright, but because they take in when the designer design, they take in account that your battery will actually deplete over time. So the approximate voltage recommended is 3 volt. So therefore, within your design, you requires 2 batteries. Alright, but actual fact, the system only requires 1.2 volt. Alright, so this is, I think they're trying to ask for this answer. I may be wrong, so keep an open mind also. So another important consideration is the sloping discharge curve. Alright, the sloping. Alright, this alkaline discharge curve. Alright, so be careful of this thing. And nonetheless, all this system, alright, can help you to predict. Alright, we want something that is predictable. As for alkaline, you may think that it's not predictable, but think about it, it's a linear line. It's a linear line, is predictable. At 50% something, linearly at 60% it may be something else. So these are the things that you're gonna consider also about when you design a certain stuff. And this thing over here, I don't know what they are trying to say, but at least I think it's the same thing as we have said earlier. I don't know. So I'll leave you to think about it for this section. Alright, at least I think you have a fair bit amount of understanding now. So yeah, this is all the things about the voltage. Alright, talking about the voltages, about the battery supplies. Okay, so later on I'll talk about the how to charge your supplies and things like that, about charging your stuff. Okay, so see you there then.